Paris gun. The Paris gun attacked a city its crew could not see. From a distance, artillery was not supposed to reach. On March 23, 1918, shells began falling on Paris even though German forces were more than 70 miles away. At first, French authorities suspected an aircraft or a hidden gun near the city. The weapon responsible was actually an enormous German railway gun firing from behind the front lines. Its barrel was more than 100 feet long and required external bracing to prevent it from bending under its own weight. The gun fired a shell so high that it entered the stratosphere, where thinner air reduced drag and allowed the projectile to travel farther than any previous artillery round. The achievement created its own mechanical problem. Every shot eroded the barrel, increasing its internal diameter. The shells, therefore, had to be manufactured in a numbered sequence, each slightly larger than the one before it. Firing them in the wrong order could cause a dangerous loss of pressure or damage the weapon. The Paris gun was inaccurate by normal artillery standards. It could strike a city but not reliably select a particular building within it. Its primary value was psychological. Over several months, the guns fired roughly 350 shells toward Paris, killing hundreds of people but failing to change the course of the war. The weapon extended artillery range so dramatically that accuracy almost disappeared. It could reach farther than any gun before it, provided nobody asked precisely where the shell would land. Schwerer Gustav. Schwerer Gustav was not transported like a normal artillery piece. A railway had to be prepared for it first. Krupp developed the 800mm gun for Nazi Germany as a weapon capable of breaking the reinforced fortifications of France's Maginot Line. It weighed approximately 1,350 tons and stood several stories high when assembled. The weapon traveled in separate sections. Crews had to construct parallel curved railway tracks, assemble the gun with heavy cranes, and position thousands of soldiers around it for operation, security, maintenance, and ammunition handling. Its armor-piercing shells weighed more than 7 tons. A separate high-explosive projectile weighed nearly 5 tons. Both were larger than many early automobiles, and each required specialized equipment merely to reach the loading mechanism. Gustav was completed too late to attack the Maginot Line, which German forces had bypassed. It was eventually used during the siege of Sevastopol in 1942, where it fired at Soviet fortifications, coastal batteries, and underground positions. The gun could cause extraordinary destruction, but only after an equally extraordinary logistical operation. Its railway tracks restricted its movement, its size made concealment difficult, and the aircraft, labor, and equipment needed to protect it could have supported many conventional weapons. Schwerer Gustav was artillery enlarged until the gun itself became a military campaign. Before it could destroy a target, an army first had to build the conditions that allowed it to exist. Little David. Little David had the largest caliber of any modern artillery weapon built in the United States, and it began as equipment for testing aircraft bombs. During the Second World War, the U.S. Army needed a way to test large aerial bombs without repeatedly using aircraft. Engineers created a device that fired the bombs from a short, enormous barrel, allowing their fuses and explosive effects to be studied on the ground. That test device eventually became the 914mm T1 mortar known as Little David. Its barrel measured approximately 22 feet long and weighed more than 80,000 pounds. The entire system required a massive steel base buried in the ground. Its projectile weighed roughly 3,650 pounds, making a single round heavier than some complete artillery pieces. As American forces prepared for a possible invasion of Japan, Little David was considered as a siege weapon against heavily fortified positions. Unlike a railway gun, it could be moved in 2 major loads using tank transporters. But describing it as mobile required generosity. Preparing its firing position involved excavating a large pit, lowering the base into place, and using heavy equipment to assemble the barrel above it. Testing revealed limited range and inconsistent accuracy. Before those problems could be solved, Japan surrendered, and the invasion was cancelled. Little David never entered combat. It possessed a barrel wide enough for a person to stand inside, yet its intended battlefield career ended before the weapon could leave its test range. V3 cannon. The V3 was not one gun in the conventional sense. It was a barrel lined with additional explosions. Germany developed the weapon to bombard London from a fortified complex at Mimoyex in northern France. Its barrel was planned to extend more than 400 feet along an inclined underground gallery. A normal gun accelerates its projectile using one propellant charge behind the shell. The V3 used multiple secondary charges positioned in chambers along the barrel. As the projectile passed each chamber, the additional charge was supposed to ignite at exactly the correct moment, increasing the shell's speed without requiring impossible pressure at the breech. In theory, the design could launch projectiles across the English Channel repeatedly, creating a long-range bombardment system that was cheaper per shot than rockets. In practice, early tests damaged barrels and produced disappointing performance. The project also required a fixed installation whose location could not be concealed indefinitely. Allied intelligence identified Mimoyex, and British bombers attacked the underground complex before the full battery became operational. The main installation never fired on London. Smaller versions were later used against Luxembourg, but they achieved little strategic effect. The V3 attempted to solve the limits of one explosion by arranging many explosions behind the same shell. The concept was clever, but it depended on perfect timing inside a barrel hundreds of feet long, while enemy bombers were working to remove the barrel entirely. M65 atomic cannon. The M65 atomic cannon turned a nuclear weapon into an artillery shell. Developed during the early Cold War, the 280mm weapon was designed to give the United States Army a battlefield nuclear capability. It was transported between two specially designed tractor units, one at each end, producing a vehicle combination more than 80 feet long and weighing approximately 85 tons. Both drivers had to coordinate their steering, allowing the machine to negotiate roads despite carrying a gun far larger than ordinary field artillery. Once positioned, the transporters separated and lowered the weapon onto its firing platform. On May 25, 1953, an M65 prototype fired a nuclear shell during the Grable test at the Nevada Proving Ground. The projectile detonated several miles away with a yield of approximately 15 kilotons. It remains the only confirmed occasion on which a nuclear artillery shell was fired from a cannon and detonated in a test. 20 M65 systems were manufactured and deployed as Cold War deterrents in Europe and Asia. Yet the cannon's enormous size made it difficult to hide, move, and protect. Rockets and missiles could carry nuclear warheads farther without requiring an 85-ton gun to travel along public roads. Atomic Annie represented the moment nuclear warfare became small enough to fit inside artillery, but not yet small enough to make the artillery practical. It was a weapon of extraordinary power attached to a transport problem almost as visible as the explosion. Davy Crockett Weapon System. The Davy Crockett was a nuclear weapon small enough to be assigned to infantry units. Introduced by the United States during the Cold War, it used a recoilless gun to launch the M388 nuclear projectile. Two versions were fielded, a 120mm system and a larger 155mm launcher. The projectile was not shaped like a conventional shell that traveled through the barrel. Its bulbous warhead remained outside the muzzle, attached to a rod inserted into the launcher. When fired, the weapon looked less like artillery ammunition than a large metal watermelon being thrown from a tube. The warhead used the W-54 nuclear device, one of the smallest nuclear weapons ever produced. Its selectable explosive yield was measured in tens of tons of TNT rather than thousands, but its radiation was the central danger. It was intended to strike advancing enemy formations and contaminate the immediate area with intense neutron and gamma radiation. That created an uncomfortable relationship between range and safety. The smaller launcher could not send the projectile very far, and even the larger version placed the firing crew disturbingly close to the effects of the weapon they had just used. Accuracy was also limited. The system depended on battlefield calculations and a projectile whose destructive radius reduced the need for precision while increasing the consequences of error. Davy Crockett made nuclear artillery portable enough for a small crew. In doing so, it also made the decision to begin nuclear warfare portable enough to travel in a jeep.